GIS-Hunter, Explore, Discover, Master. This is a game that utilizes GIS software at its heart to make learning the skills of GIS fun and entertaining. So as I discussed the why for this particular game, I'm going to go a little bit into what is GIS and how is it currently used. So I'm going to get out of this presentation real quick and scroll over to an online database of GIS maps. So GIS takes a data set and adds it to a map to visualize it. Now, currently, the most powerful software is desktop software, but here I have ArcGIS Online Explorer, so I can see various maps that people have created and shared. Over here I can see ecological footprints, carbon dioxide emissions, greatest sporting nations. So it's taking a data set and adding it to a map to visualize it. If I click up here, this particular map looks like a normal terrain map. I'm going to go ahead and zoom in on this on the United States and just show you that in addition to data sets, you can manipulate the maps a little bit more. If I just want to actually go ahead and calculate, say, a distance in miles, say from over here in California to the East Coast. So it'll easily do that. I can change the units very easy. I can even go ahead and calculate, say, an area by clicking in various places. And square mileage, square footage, you name it. These are just some of the basic features that this program is going to allow us to do. Okay, so square meters, square miles, for instance. I can click on any point on the map and say, where am I right there? And it's going to give me my latitude and longitude. So that's just one particular map and some of the things I can do with it. Another map I have up here is the carbon dioxide emissions. And this one's actually animated. So if I hit play, I can actually see the circles changing from 1960 to 2007. So it's just another example of how this software is currently being used. Another map here. This one is going to the import and export of plastic waste. So these maps are all over the place in terms of their content, but remember they're data sets that someone has compiled and then placed them onto the map. So GIS is much more than Google Earth. It does much more computation, if you will, than Google Earth. So it's very versatile. And we're starting to see classes being created at the high school level around this particular software. So if I come back over here, so GIS, it's the software base and it's starting to be used more and more. Now, why are we interested in GeoHunters at Castleview? Well, we have a Geospatial Technologies and Environment class. We're one of the only high schools in the entire country that has a class like this. And so here I have the description from our course catalog. You can see prerequisites are biology and chemistry. It does use, as I said earlier, state-of-the-art GIS software, desktop software. And at the heart, it's a very inquiry-based course investigating national and global issues. So we have the class already. It's on the rise. It's more and more high schools are going to start having this, and kids are going to demand to be trained on GIS. So in our current class, students utilize the software to accomplish tasks, like, for instance, where in the United States could you construct a wind turbine farm? And to accomplish this task, they're given certain parameters like specific acreage, land use, elevation, can't be next to an airport, can't be next to this. And so that's currently how we're using it. And a good portion of our class is spent transitioning from one task, like use GIS to calculate this, or use GIS to find this particular site, one task to another. Using GIS-Hunter, the game can accomplish the same tasks, but in a fun and more entertaining team environment. We may remember Where in the World is Carmen Sandiego? I envision GIS-Hunter being kind of like that, a little bit like Indy, and a little bit like The Amazing Race. The story behind this game. Thieves have stolen valuable artifacts from locations around the world, and your job as the GIS-Hunter is to retrieve these artifacts. To accomplish this, you're going to have to use your scientific knowledge, of GIS, your GIS skills, and also your background knowledge of chemistry and biology, the prerequisites for the course. So how does the game work? Well, it's a computer game, and so students or players will log on. It could either be downloaded on the desktop, but you're going to need internet connectivity, or an online actual game. And the interface, I envision, will look something like this. So there's different sections of the interface, if you will, the game environment online. Up here, I would imagine the map dashboard. Over here would be like your map, your interface, the various types of maps you can use. Upper left would be a progress meter, because in the game, you're going to go to a certain location and have to answer questions and actually progress through a certain location before you recover that artifact, and then you're going to have to go to another location to find another artifact, and so there'll be some type of a progress meter that tells you how far along you are in actually retrieving the artifact. Over here would be the Q&A interface, where you're going to be asked questions, content questions, and have to enter answers, or actually enter information from your map interface that you're analyzing with GIS. And in the lower left-hand corner, there's going to be some type of space here for a calculator function, or say a computational search engine. So putting this all together, it could look something like this. So notice the dashboard up top. There's a map here of Greece, I believe. Upper left-hand corner, you can see some type of progress meter, question and answer, and lower left, there's a calculator function, or in this case, Wolfram Alpha, so that things can be looked up with that internet connectivity. So I would envision the interface for this game looking something like this. Now, the game's going to start essentially with player receiving the coordinates to the first location where an artifact needs to be retrieved. So using the GIS software in the interface, they're going to go to that location and begin the quest to recover the artifact. So in this case, this location will take us smack dab to the middle of London. And so once in London, in this interface, the Q&A box that I'm pointing to right here, there'll be a certain question that's going to be asked for the player to answer. And so in London, you're going to be able to progress and slowly zero in on where that stolen artifact is. So question could be, well, first of all, where in the world are you? So the player can type in, I'm in London, England, and go ahead and submit a response. Another question, like task number 2, still in London, using GIS, determine the area, square meters, of the inner grounds of Buckingham Palace. And a little hint there, and so using the map feature on their interface, they're going to go ahead and find Buckingham Palace, and there's different maps that they can use for this, topographical or something like this particular map. Find Buckingham Palace, and then go ahead and use a feature that they can click around in the inner court there, and actually find out that they're going to say the square meters. The area is going to be 3,990.19 square meters, and they'll go ahead and enter that in the answer place, and that's going to go ahead and then progress them to the next clue within the city, which could be another GIS clue, or it could be a content question about chemistry or biology, or some type of scientific question that they want to progress. Now eventually they'll go ahead and the progress meter is going to take them to a point where they say, you've recovered the artifact, congratulations, and they're going to get a new set of coordinates to another area, another place in the entire world to go find another artifact. And then when all the artifacts are found for that particular level, they could advance to an additional level, and all the tasks get more and more challenging. So the players are going to be awarded point values when they correctly answer each question. Now, the points may vary depending on the accuracy. For instance, if you answered 3,390 for that last question that was asked, and the accepted area is 3,394, then you're going to get points. You're going to get more points than someone who, say, answered 3,375. So your point value is going to depend on how accurate your answer is. And so while you're at a certain location, you can have some type of progress meter that's going to tell you how far you are within that location. So if we're in London and we answer maybe one question, we might kind of tick forward to slight progress, second question moderate, and then we'll complete the task in London, recover the stolen artifact, and then receive the clues to the next city for the stolen artifact. Now, like I said earlier, each level will include more difficult questions and sophisticated GIS skills. Players can go back, however, and repeat a level if they want to increase their points. Now, this will accomplish the following learning objectives in the GIS class. Players will master various GIS skills. They're going to incorporate scientific knowledge from course prerequisites to answer questions, and they'll solve timely and relevant problems and be able to incorporate an element of mastery learning by going back to increase their point total. GIS-Hunter can replace many of the procedural labs and activities that the course currently has by adding collaboration, resourcefulness, and the element of mastery. Additionally, points can correlate to course progress and mastery, which can ultimately transfer into a grade of sorts. So essentially, all the labs and activities can be incorporated into this online GIS-Hunter game. And your points can translate into a grade, which is determined by how well you handled all the various tasks and the GIS skills. So that's GIS-Hunter, Explore, Discover, and Master, a GIS-based game and a computer game that can be utilized in our Geospatial Technologies class at Castleview. Thank you very much.